Okay, we're talking about 9-4 rational expressions. I got a little bit ahead of myself, so the fractions you see on my screen, don't write those down right now. We'll do that tomorrow or a different day, but don't write those down right now because that's actually for the next lesson. Sorry I got ahead of myself. We are talking about fractions, and we'll get into more of the adding fractions a different day, but these are called simplest form fractions, and when something's in simplest form, it cannot be reduced anymore. A very common thing for a lot of Algebra 2 kids to do is to try to cancel out these x's. Some of you have been known to be doing that even in Chapter 7 when we were dividing functions. That's not possible. X and x minus 1 are two completely separate factors. It sounds like you are confusing an idea of multiplication, which we'll get to in a second. This is also in simplest form. Nothing cancels out. None of the factors in the numerator cancel with any of the factors in the denominator. Now, this is what a lot of the Algebra 2 kids are thinking about, something that's not in simplest form, and that would be when you can get rid of one of the x's, right? Because you really have x over x times x. This is when we can do that crossing off idea, giving us as a final answer. That other solution we couldn't have. We'll get into the complex fractions, right, where you have a fraction over a fraction or something like that, a fraction inside of a fraction. That gets into more of the, you can write it as 1 over x divided by x plus 1, or 1 over x times its reciprocal. We can do that kind of stuff, multiplying by the reciprocal. Simplifying this fraction, I see an x minus 3 and an x minus 3, so the answer to that would be 2/3, but it wasn't a simple fraction to begin with. We're talking about example 1 here. It says simplify, stating your restrictions on the variables. You will have to factor everything under the sun that you can find to factor. So let me get started on the factoring here. We've got x squared plus 10x plus 25. That's x plus 5 times x plus 5 over, now, factors of 20 whose sum is 9. That would have to be plus 4 and plus 5. Okay, so now we've factored everything we could possibly factor. There were no greatest common factors, so I didn't have to worry about that. Let's check the restrictions. Restrictions are things where the variables cannot be, and they have everything to do with the denominator. X cannot equal -4. X cannot equal -5. Those are my two restrictions on the variable, -4 and -5. But in order to finish this, I noticed that those two factors cancel out. So my final answer, x plus 5 over x plus 4, with these restrictions. On the next question, there's not a whole lot of things to factor because everything's already factored, which is nice. You can treat this as 3 separate fractions that are all being multiplied together if that's more helpful to you. Multiplication works that way. Addition and subtraction do not, so don't try that trick at all on those. So we can simplify this to -3. Let's see, if I get rid of 3 of the x's, that still leaves an x in the bottom. And if I get rid of both y's, my final answer is -3 over x. Now, what are the restrictions? Well, right here you're going to find a restriction. And right here you're going to find a restriction. X cannot be equal to 0, right? Because 0 to the 4th power is 0, and that would cause a huge problem in my denominator. Also, y cannot be equal to 0. That would also cause a big problem. So, here's my simplified answer with my restrictions. In the next example, they're going to do something kind of tricky. Most Algebra 2 kids are not going to see what they are going to do this first time. So I need to show it to you. Every time the x comes second, they're trying to play a trick on you. There's a negative multiplier or negative greatest common factor that you need to pull out of that numerator. So if I pull the negative 3 out, I'm left with x minus, or x, I should say x plus 2 in the numerator. Now that looks a lot nicer than the previous one. Now if you don't know how I did that, I took negative 3 out. I divided this by negative 3, that gave me positive 2. I divided this by negative 3, that gave me positive x. But just for fun, I decided to flip it around so that it looked more like what you're used to. Then you've got to factor the bottom. I don't see a GCF on the bottom, so I just need to go right to my factoring. Factors of 8, whose sum is 6. It looks like both of them have to be negative. Well, take a look at it. Nothing cancels out. There are no factors that cancel out in this entire thing. So I can go straight to my restrictions. X cannot equal 2 and 4. Those are the restrictions. Okay, in the next example, well, once again, going to be factoring. I look for a GCF, no GCF in the top or the bottom to worry about. So I can just start factoring this thing. Maybe you want to use my magic trick that I did before on this type of stuff, where I would take the 2 and multiply times the 2, get x squared minus 3x minus 4, and then I would factor it, leave some room in front of your x's to put 2 back in. I've got a minus 4 and a plus 1. That would give me a sum of negative 3. Oops, sorry. A little bit too far up. Plug your 2's back in. Pull out a GCF. And when you pull out a GCF and throw it away, you get this. This one doesn't have a GCF, so you don't have anything to do with it, or don't have anything to pull out and get rid of. This one factors nicely. X minus 3x minus 2. Product is 6. Sum is negative 5. Okay, so I've got it in that form. What are my restrictions? X cannot be equal to 3 or 2. 3 or 2. Now, I can reduce that a little bit now that I've gotten my restrictions, so that my final answer is 2x plus 1 over x minus 3, as long as x does not equal 3 or 2. 3 or 2 would be the restrictions. Okay, more examples, just because you guys need as much practice as you possibly can get. We're factoring everything under the sun. If you want to use our little trick that we talked about with this one, because there's no GCF to worry about, that would be x squared plus 7x plus 6. Factor it normally. Got an x plus and an x plus 6 and 1 would be the factors. And then I can plug my 2 back in, get rid of a GCF there. So that's x plus 3 times 2x plus 1. I have the x minus 4 in that denominator. The x squared minus 16, well, oops, that's not equals, that's times. That's a difference of perfect squares. We should recognize that one, right? Factors of 16, whose difference is 0. There wasn't a GCF in that bottom either to pull out, so I've got x factors of 15 that add up to 8. That would be plus 3 and plus 5. What about my restrictions? Well, let's see. X cannot equal 4. X cannot equal negative 5. X cannot equal negative 3. So I've got all my restrictions. If you don't remember that, just set each one of those factors in the denominator, only the denominator, set each one equal to 0 and solve for x. That'll be another way you could do it. Well, you have 4 factors on the top. Really and truthfully, remember, multiplication of fractions is across the top and across the bottom. So it's really like one giant fraction. Now you can't do that trick with addition, and we'll talk about that at a different time, but you can with multiplication. Look at what cancels out. I see an x plus 3 that cancels out. I see an x minus 4 that cancels out. So I'm left with 2x plus 1 over x plus 4 divided by x plus 5. With restrictions of x cannot be 4, negative 5, or negative 3. I am not, hear me out, I am not going to ask you to FOIL the top. This is not about having you refoil everything together. If you get done and you have extra factors, leave them. Don't worry about that. You're wasting your time if you do that. I don't need that. What I need you to understand is how to factor it, look for factors that cancel, and give me the restrictions. That's the main point of what we're trying to do here, not can you refoil when you're all done. Okay, so I've got this particular problem. No GCFs. Oh, I see a GCF right down there, but we'll deal with that in a second. A difference of squares there, a plus 2, a minus 2. I see a difference of squares in that denominator, a plus 1, a minus 1. I see a numerator of a plus 1, and I see a denominator of a times a plus 2, because I took out the GCF. Remember, this is one giant happy family. Numerators all together, denominators all together. Restrictions on the variables. A cannot be negative 1, positive 1. That's one we haven't talked about in a while. 0 and negative 2. Cancel out anything you see that you can cancel out, right? There's one from the top and the bottom. There's one from the top and the bottom. So we have a minus 2, and then we have a times a minus 1. Once again, don't need to distribute, don't need to refoil, whatever. Just leave it alone. You've done what you need to do for that question. So what happens when you get to division? In division, which is what example 4 is about, we need to factor everything. Well, if you look at this problem, almost everything's factored, except for one thing right here. I noticed that there is a negative in that one. All right, so there's a little dirty trick that they tried to play on me. I'm going to take a negative 1 out of that, which would leave me with x minus 4. The bottom is already factored of that. I'm going to leave that alone. And everything on this side is also in factored form, so I'm not going to worry about it. Okay? Now, once you've gotten everything factored, you've got to check your restrictions. Before we do anything else, we're going to check restrictions. So, set each one of your factors equal to 0. That one's a little bit trickier. 3x plus 2 equals 0. 3x equals negative 2. So x cannot be negative 2/3. X can't be 2. That one's already over here, so I don't have to worry about it again. Then I got this one, right? 7y minus 5 equals 0. That would mean 7y equals 5. Or y equals 5/7. That's another problem. Y cannot be equal to 5/7. That's even a separate variable. Okay, so let's see here. I'm running out of room, so I'm going to move over to this next page. And what I want you to understand is back in middle school, we changed our division questions to multiplication by the reciprocal. So you got to remember that this second fraction is going to flip over. So when I recopy it down over on the next page, it'll look a little bit different. I still have the negative 1 times x minus 4, and the 3x plus 2, and the x minus 2. But I'm changing this to multiplication. And the 5 times x minus 4 goes down to the bottom. And the x minus 2 times 7y minus 5 is in the numerator. Okay? And then this is going to be just like the good old happy family, all the numerators together, all the denominators together. Um, we do have a new restriction in town. Now, the 5 is not going to cause a new restriction, but this x minus 4 causes a new restriction. So we're going to have to come over to our list of restrictions, and we're going to have to add that. X cannot equal 4. So that's another one that we have to add to our list. So not only did we have to check before we flipped it over, we also have to check after we flipped it over. And now, just like we did before, we're going to go through and we're going to get rid of anything that's a factor from the numerator and denominator. I see those two. I see these two. Don't forget, you got a negative 1 there. So we got a negative 1 times 7y minus 5. You've got a 5 in the denominator and a 3x plus 2 in that denominator. So that's my final answer. And I've got a bazillion restrictions over here that we already had copied down. So you've got those all those restrictions that we talked about, and then a simplified answer. One last example before the children interrupt my video, which they're about to do. Okay, and I'll pause it. Talk to you later. Back by popular demand for the last example. We need to factor everything we could possibly factor. So let's see here. This numerator can be factored. I don't see any GCS. Oh, no, I take that back. I see a Grady's common factor down here. Okay, so I'm going to factor this. I've got A and A. Factors of 15 whose difference is 2. Factors of 15 whose difference is 2. That would have to be 5, positive 5, and negative 3. On the bottom, I see a difference of squares, right? A plus 4 and A minus 4. And then over here, I see A plus 1, and I see 3 that I can pull out of there, which would give me A minus 4. Okay, so I've got that. Now I can do restrictions over here just for fun. A cannot be equal to negative 4 and positive 4. Right? Negative 4 there, positive 4 here, and that's just a duplicate. The 3 isn't going to magically turn into a 0, so you don't have to worry about it. Okay, now, we'll change this to a multiplication problem by leaving the first one alone and flipping the second fraction, right? 3 times A minus 4 goes in the numerator. A plus 1 drops down to the denominator. Oh, look! A new restriction. If A plus 1 could possibly be 0, then negative 1 has to be added to my list. So I've got negative 4, positive 4, and negative 1 in really sloppy handwriting. Next, remember we could treat everything like it's all one fraction, numerator and denominator, so we can start looking at canceling things out. Well, that's it. The only thing I can cancel was the A minus 4s. So we have 3, A plus 5, and A minus 3 all over A plus 4 and A plus 1. No, I do not want you to FOIL all that stuff together and waste my time. So that's the simplified answer. It's as simple as we're going to go. And then those are my restrictions for negative 4 and negative 1. And that's all for lesson